is a demo of the node generator part of the Obsidian Assist tool. If you look at the README, this is the part that we'll be demonstrating in this video. So let's jump right into it. But before we start, I would expect you to already have configured it with the Docker images that are suitable for your machines. So over here in this tool, as you can see, first of all, it's a Gradio app, right? Gradio, I can't recall how it's correctly pronounced. But the one panel you'll see on the top that is consistent throughout these options, either you go to chat or you go to generate notes. This is the one, like the first three options are for selecting the LLM or the large language model you want to use, right? So over here you have the option of using Gemini with the specific one you want to use, or you can go with Hugging Face. This will use the inference API, right? So I mean, by default it has this option, but in case you want to use something specifically from some other model, you can always go to text box and just like paste the name you will see on Hugging Face. And then you have Ulama. Ulama, I'm sorry, my pronunciation is not. So over here, it will just list down all the models you have installed on your local Ulama setup or installation, essentially, right? But for this example, I will be demonstrating it with Gemini because my machine, the one I'm demonstrating it on, it's not that strong. So I mean, with Ulama, it will be really slow, and also I won't be able to load up bigger models. So after these three options, this option over here, it is for it's more relevant to the generate node and chat options over here. In fact, like all these options would be used in generate nodes and chat. Like, and as you're using either of them, you can change them up. But this max cosine distance is used when you do semantic search, right? When you are for these purposes, by default it's using sentence transformers. And over here, like the lower it is, the smaller I would say the fewer matches you'll get because it will really try to look for something that's really identical to the text you're using. So yeah, in case you're doing something and you're not getting that many matches, and if you're sure about it that you should get more matches, just like crank this up. But by default, it comes at 0.3. So yeah. Now, after I've covered the LLM side of things, so before I demonstrate how to start the node generation process, let me just talk about the documents we're using for this demo, right? Let's see. Talk about yeah. So I'll be using these publicly available open source textbooks from OpenStax. Yeah. So I'll be using the economics textbook, the organizational behavior textbook, and the psychology textbook. Where is it? Yeah, the psychology textbook, right? You can check out the chapters over here. You can download them locally. And according to GPT, I should specifically mention, yeah, access for free at openstacks.org, right, and everything else. So yeah, now that that is done, let's start with the node generation process. So the first option, filter on headers. What does that mean? Well, you see, if this is checked, then there's like this local list over here of the certain headings to avoid. So essentially, I'm using Docling underneath all of this to Docling to convert PDFs and PPTs to Markdown files, and then those Markdown files, since they are like really structured, right? I use LangChain with its Markdown functionalities to sort of segment the text and then create notes out of them using with LLMs and vector DBs and everything. So if you have this on, it will skip certain segments of the text that start with these headings, right? And like this is something that's just hard-coded right now. If you can uncheck this if you want. Yeah, restrict links and context to vault. So before the so over here, right? Over here, you will specify the path of your vault, like where you want the nodes to be created. And if you check this, then what will happen is that the links that are created between your nodes, it will be limited to the nodes that already exist in the vault you have defined, or else it will refer to anything that matches it, irrespective of the vault that thing is in. So yeah, it's your call. Sleep time is for handling rate limits and stuff. So this what you're seeing over here is seconds, right? So essentially what this says when it's at 5, it says that hey, between every single API call, um, keep a gap of 5 seconds, right? Don't just like continuously make those calls. And then this max LLM retry right over here. This is the one that in case the LLM doesn't respond in the specific format you want, and we are looking for a JSON format over here so that we can like format our Markdown node in Obsidian, and it will make a bit more sense as I show you what is the end result. So that is what you're defining over here. That for a certain segment of text, how many times should the LLM try to create a node, right? I mean, if it can't after the specific max you have defined, it will skip that segment. Yeah, and like normally it gets it in the first try, but in case it's something super complicated, like super complicated or something that normally there are issues with, like in encoding in JSON and stuff, it can happen. Yeah, and then the sleep time is like the time between those consecutive or concurrent LLM calls, API calls. And I think this would come into play not for local LLMs, like if you're running for something on Ulama, I don't think this is an issue for you, right? Because it's your machine. But if you're using some other service, you don't want to run into those rate limits and stuff, right? So yeah. Now the source file path. Now, depending on how you have installed this, like if you went with the local installation, and let me switch to the repo over here. So you have two options, right? One is like you can just install it with the Docker. Yeah. So depending on GPU or CPU, you clone the repo, You clone the repo irrespective of how you're installing it, even if it's a Docker or with the local method that's listed over here. Um, so if you are doing it locally, then just like give it the paths as you would normally to your file or directory, and I'm going to cover that a bit more. But if you're doing it with Docker, right? So in case of Docker, the Docker image or the container has to be mounted to some local directory on your uh, system. So for I have configured it to just like attach to downloads directory. Like I mean, and this can be improved, I think. But for now, if you want to read or write to anything, it should be in the download directory of your Windows. I haven't tried it much with a Linux or Mac, but I think this should work for them as well. And I'll just demonstrate how it's done for Windows. And yeah, if there are any issues, just create like over here, right? You can raise an issue. So yeah, like over here. Now for the source file path, right? The source file path, it could either be a specific markdown file .md or a PDF or a PPT, or it could be a directory that contains any three of those. Like it could be a bunch of it. I'll demonstrate in a bit. And you might be wondering that over here, like I would have downloaded a PDF. So and then like with this script over here, yeah, I converted that PDF to a Markdown file. Why did I do that? Because Docling, if you're converting a PDF to Markdown, there is a chance that it might be a computationally expensive or taxing process. And if your computer isn't, let's say, strong enough or that beefy, it might take a lot of time. It will happen, but it might take a lot of time. So I would suggest that, like, just taking this notebook and uploading it to maybe Google Colab or Kaggle, and then converting your PDFs to, let's say, two Markdown files, and then using those Markdown files directly because that really speeds up the process. And over here as well, you have the option of like, you can just upload an entire directory of PDFs or PPTs and like just convert them to Markdown. So you can go with like specific single PDF, a single PDFs, right? It's your call. So yeah, and so in my source file, I have given the file, and then in the vault, like this is where I would want to essentially save my notes that are created. Over here on tags, so LLM by default, I mean, with this approach, we automatically try to create tags for every single node, but in case there's some specific tag that you want to be there, in that case, I would suggest you just add that over here, right? And like here, tag separated by hashtag, right? So like just space, and that's what you want, right? No commas, nothing. And I have opened the vault over here, and as of now, it's in the graph view, and you can see there's nothing over here. There is one directory for economics and management, and another directory for psychology, and right now we're trying to update things for psychology. Okay, and I'm going to just run this. Yeah. Okay. Yeah, so, all right. It's starting. Right now, it's like saving to VDB. VDB is vector DB. So it's right now saving things to vector DB. And I'm using Chroma DB for the vector DB part of things over here. And once that's done, it will start the node generation process. Nothing over here right now, obviously. All right, it has begun. And let's see. For psychology textbook is complete. And if I go in here, let's say for health psychology and biopsychosocial model, we can see a lot of linked nodes over here that are automatically created in the process, right? You have these pictures and everything that I extracted from the textbook. Yeah, a simple explanation of what this node is about, etc., etc. For the important snippets, I beg the LLM to quote passages from the text verbatim. But yeah, so now again, I will be adding one more, generating notes from one more textbook. But again, this textbook is also taken from OpenStax, and yeah, just add hashtag OpenStax. And in case you notice, this hashtag was added over there, along with a lot of other ones that were generated by the LLM. So OpenStax, like this is the one we provided, and then these others were suggested by the LLM, right? So over here, development psychology, etc. Lifespan overview, yeah. All right. So I'll just start this and let's see. So I mean, I would want the nodes that are generated in organizational behavior textbook to weekly refer to psychology if in case because it's just for demonstration purposes here. So like let me increase the max of sign distance over here. Let me make it 0.7. All right. Now let's see. Yeah, so OpenStax, let's give it a shot. Mhm. So it got 1,167 segments. And it should begin. So okay, and it has begun. So yeah, if I go to the graph over here, I think I might see nodes popping up. Yeah, it's happening. So all right, so the node generation for that organizational behavior textbook is complete. And as over here, the red nodes or the red dots, if you would, are the nodes created from the psychology textbook. And the green ones are the one created from the organizational behavior textbook. And if I were to explore any one of these, let's see. Yeah, let's check this out. So if you would see this specific segment that was eventually converted into a note in Obsidian, which comes from the organizational behavior textbook, is related to some other note in the psychology segment. For example, work group dynamics and dynamic structure, social roles and their influence and behavior, work groups significantly influence individual behavior, individuals and groups may limit their income to match group members only. Some people stay in undesirable jobs due to friendships, formed in workplace, group interactions, impact performance, all those specifics of impact are not fully understood. And what essentially it's trying to say is, okay, so imagine your friend group, that is if you work group, but instead of doing homework or hang out, people go differently than they're alone, like maybe you only make certain jokes. When you're with your friend, groups have rules, like always being there for each other, everyone has a role too, like the funny one or responsible one, groups stay together for safety, to have fun. All right, and what are the psychology ones about? Yeah, I mean, yeah, it's building connections to those group psychology things, right? So just to reiterate, this one comes from the organizational behavior textbook. And if you look at something like social roles and their influence and behavior, social roles represent patterns of behavior expected of individual within a specific setting of groups. All right, so yeah, it's building connections to those, right? Yeah. So again, this is the entire graph over here, and now I'll be adding the economics textbook. So I'll be adding the economics textbook again, a similarity of 0.7. 0.7 might be too high for our purposes. Like, and this cosine distance thing, it's more of subjective thing. Like, how much do you want your nodes to connect with each other, right? I mean, if you're really looking for connections, you can just crank this up to 2. But like, not every connection would be meaningful. You'll get a lot of edges, a lot of connections, but not everything would, I would say, make sense. So yeah, like let me set this to 0.5 maybe. Yeah, I think 0.5 is good enough. And then yeah, let's start generating nodes. And the node generation is complete. So the blue ones are the economics textbook. Yeah. Yeah. The red ones psychology, and green ones are the organizational behavior textbook. All of them segmented and then converted into connect interlinked nodes. So yeah, thank you for watching.